notes today, and then you do have the rest of the time to kind of get work done that you might have missing or that you need to redo. All right, so for this first one, in test for parallelograms, we're going to be flipping back and forth between this and the foldable. I'm not super great at showing the foldable, so when I say look at your foldable, I'm talking about this thingy. Okay? So you're going to want to flip back and forth between those. It's really nice if you have it back to back. There's some of you that have it like foldable right next to it. That's nice. All right, our directions for these first 5 problems say to determine if we have enough information to call each quadrilateral. Determine, no, this is 6-3. Good call. Sorry. Determine if we have enough information to call each quadrilateral a parallelogram. There should be no is there, sorry. And we need to justify our answer. What does that mean to justify? Whoa. Find the evidence for your answer. I was just going to say, like, explain, but yes. Find the evidence for your answer. All right, so in this first problem, we have this quadrilateral. We have this 4-sided shape. What information are we given on the diagram? What markings do they tell us? What do these little things mean here? Congruence. We know this part is congruent to this part. And what other parts are congruent? Yeah, that other diagonal. So this isn't based on the definition, because the definition of a parallelogram says that the opposite sides are parallel. We don't have those parallel markings, but we have these congruent symbols. So if you look at your foldable, is there a theorem about these diagonals being congruent and a parallelogram? Which theorem? Theorem 5? Yeah, it looks really similar to that. Theorem 5 says the diagonals bisect each other. So for this one, does it bisect? Do they cut the diagonals in half? Yeah. So can we say it's a parallelogram? Yes. So we're going to say yes. And our explanation, our evidence is theorem what? 5. Now, next year, if you go up to your Algebra 2 teacher or your Advanced Algebra 2 teacher, and you're like, last year I learned about parallelogram theorem number 5. Do you think they're going to know exactly which theorem we're talking about? No. We just called it 5 so that when we say 5 in this classroom, you guys know which one we're talking about. You know where to look. Does that make sense? Also, when you do your test, next week, it's going to be okay. You have a test next week, it's going to be okay. Well, plenty of time. Okay, when you do your test and you need a theorem, rather than typing out the whole theorem, you can just say theorem 5 and I'm going to know what you mean. Okay, if you really want to type out the whole theorem word for word, you're welcome to, but that sounds like a lot of work. All right, next one. What information are we given in this quadrilateral? Yeah, how did you know it was parallel? Yeah, those arrows. So I know this side is parallel to this side. Okay, so I know that those two sides are parallel. If you need to write that because you forget what those triangles mean. We know two sides are parallel. Is that enough information for us to say, yes, it's a parallelogram?
Two parallel sides, does that tell us the whole thing is a parallelogram? No.
No. What other information would we need to know in order to say it's a parallelogram? Yeah, the other two sides. We would need to see that these are parallel. So, can we say for certain that this is a parallelogram? No. Could it be? Yeah, but we don't know for sure. So we're going to say no. And then we're just going to say not enough information. That's not how you spell enough, though. I've spelled enough. When I was typing this, I spelled enough with an F. I literally spelled it E-N-U-F. I've never done that in my life. So weird. All right, next one. What are we given for this? Are they sides? Angles. Which angles are congruent?
All to each other?
So 118 is congruent to 118. And 62 is congruent to 62. I didn't do a super great job of that. And now this won't work. Alright, so you don't know anything about them being parallel, which means we have to look at those theorems. So we're looking at one of the theorems that has to do with angles. Which of the theorems has to do with angles in general? Which numbers? Which of those 6 has to do with angles? There's a couple. 2 and 3, 4 kind of, but 4 has to be a right angle. So is it going to be theorem 2 or theorem 3? Are we looking at opposite angles or are we looking at consecutive angles? Opposite. So is opposite 2 or is opposite 3? 2. Yep. And if you're not sure, lift that up and read. Opposite angles are congruent. So this one, do we have enough information? Yes, because it works with our theorem. So we're going to say yes, and it's theorem what? 2. All right, what information are we given on this fourth one? Congruent. What's congruent? Good, opposite sides. If you want to mark it, you can. At this point, you might be like, okay, I see that. If you're like, what are we looking at? We're looking at those tick marks. This is congruent to that. And this side is congruent to that side. We don't see anything being parallel. If we saw those arrows telling us parallel, then we could use the definition. But since they don't see those parallel, we're going to use a theorem, one of the rules. Is there a rule that tells us that opposite sides are congruent? Yeah. Which one? Yep, the very first one. The very first one tells us opposite sides are congruent. So this was a yes. We know for sure this is a parallelogram. And it is theorem 1. Alright, one more of these and then we're going to do a quick proof. I know you guys think that I'm always joking when I say it's a quick proof, but it is actually like a, I don't know, this one you thought was a pretty short proof, right? Yeah. Alright, last one for this one is this bottom one. What information are we given? Parallel and congruent. Yeah, these two sides are parallel. What part told me they are parallel? The arrows. What part tells me that they are congruent? The lines. Okay, so I'm going to write that. If you need to write that down to remind yourself what this meant, you can. If you looked at this and you knew right away it's parallel congruent, you don't need to do that. But what we know is that two sides are parallel and congruent. Thanks. You just leave that open. Thanks, Sissy. All right. Do we know that opposite sides are parallel? All four are parallel? No. So when we look at our theorems, we're going to look and see, is there a theorem that says if it's parallel and congruent, that means it's a parallelogram? Do we have any that we marked like this with the arrows and that congruent sign? No. This one's not one of the rules. So can we say for certain that this is a parallelogram? No. Could it be? It might be. We just don't know. So we're going to say no. And what's our justification? Good. Not enough information. They could have just told us that the other side is parallel, and that would have been enough. They could have told us that the other sides are congruent. That would have been enough information. They might label all the angles. There's lots of reasons that we say not enough and not just exactly because they need to tell us this. So it's not always just a one thing. Okay? All right, we have one proof left. Just right at the top. All right, for our proof, it doesn't tell us the format it wants our proof in. It just tells us what we're given and what we're trying to prove. So remember, so far we've learned 3 different formats. We've learned a 2-column proof. We've learned a flow proof. That's the one with the arrows. A 2-column is where we draw the lines and you go 1, 1, 2, 2, 3, 3. Or we learned a paragraph proof where you write it in full sentences. Which kind of proof do you guys want to do for this one? Do you want to do a 2-column? 1, 1, 2, 2, 3, 3. Do you want to do a flow proof where we kind of draw arrows from idea to idea? Or do you want to do a paragraph proof in full sentences? Here's flow proof. What did you say? Flow proof? Everyone say flow? Everyone say flow. That's crazy. Like 4 years ago when we got this, no one liked flow proofs. You guys are like all about them. I like flow proofs. All right, so we're going to start with our given. And our given is that WXTV is a parallelogram. And we're going to separate that from the other given. That was one of the parts that was given. What was the other part that was given to us? Yeah, ZYVT is a parallelogram. All right, I just shaded mine in a little bit different colors there. I did pink for my WXTV. That way when we look at it, we can kind of talk about it in the same format. And then I did orange with my ZYVT. If you want to color code yours too, you can, but you don't have to. Alright, so in the end, our goal is to compare WX with YZ. Okay, so are we talking about angles or are we talking about sides? These? Is WX an angle or is WX a side? A side. So we're looking at sides. So let's start with this pink parallelogram. And let's talk about those sides using one of those. So in the pink parallelogram, does the pink have WX or does the pink have ZY? WX, okay. So if we look at WX, what do we know WX is the same as in the pink parallelogram? VT, because it's across from each other, they're opposite. So WX is the same as VT. Which theorem tells us that opposite sides are congruent? If you're not sure, flip back to your foldable. Theorem 1. But what's kind of goofy about this pink and orange parallelogram? What do you notice is different about this compared to like two parallelograms? What's the same about them? They share VT. So if I go to this orange parallelogram and I want to make a statement about VT, but now I'm looking at just the orange one. What's the side across from VT in the orange parallelogram? Yeah, ZY. And again, that's because they're opposite sides. So that's theorem 1. All right, now you have to think way back to chapter 2. We've used it a lot since chapter 2, but we learned it originally in chapter 2. If this is the same as this, and now we know this is the same as this, what do we know about all three of them? Yeah, they're all the same. So can I conclude that WX is congruent to ZY? Yeah, because if this is the same as this, and this is the same as this, right? If Sophiane is the same age as Miss Soiter, and Miss Soiter is the same age as Fatou, Sophiane and Fatou are the same age, because everyone's the same age. Okay? So we're going to use that. We know that these are going to help us come to that last part. So we know that WX ends up being congruent to ZY. Does anyone remember what's that theorem that says if this is this and this is that, then we go from here to here? Ah, transitive! Oh my gosh. It's kind of like transportation, transitive, or moving around. That's what that prefix means. Wonderful.